Okay, Assalamualaikum warahmatullahi wabarakatuh. So on this video, I want to discuss how to solve a problem solving involve pH value, uh, concentration of hydrogen ion, concentration of hydroxide ion, and Kw. Okay, let's refer on the example. We shall calculate the pH of 0.00150 mole per decimeter cube solution hydrochloric acid. Okay, the acid is strong, so for dissociation produced, okay, for the strong acid, it will ionize or dissociates completely. Okay, so that's why concentration of hydrogen ion is equal to the concentration of acid. Okay, this is for monoprotic. If the diprotic, concentration of hydrogen ion times 2. Okay, to the concentration of acid. If the diprotic, concentration of hydrogen ion times 3 from concentration of acid. Okay, so the pH value is equal to the negative log concentration of hydrogen ion, which is 0.00150, and the answer is 3. Okay, now please look at the question number 1. Okay, a solution at 298 Kelvin. Okay, so we can apply ionic product constant. Okay, has a concentration of hydrogen ion 5.60 times 10 negative 8 mole per decimeter cube. Calculate the concentration of hydroxide ion and determine if the solution is acidic, neutral, or base. So in this case, we have to calculate the pH value, and we have to calculate the concentration of hydroxide ion. Firstly, we have to calculate the concentration of we have to calculate the pH. Okay, write the this one is solution. Okay, pH equal to negative log concentration of hydrogen ion, so equal to negative log 5.60 times 10 negative 8, and the answer is 7.25. so this is weak alkali. Okay, next, by using the formula of ionic product constant, we can calculate the concentration of hydroxide ion. So Kw divide concentration of hydrogen ion. Kw 1 times 10 negative 14 divided by 5.60 times 10 negative 8, and the answer is 1.785 85 times 10 negative 7. Okay, right, and then okay, so that's all. Okay, now we know the concentration of hydroxide ion. So this is how we use the ionic product constant to calculate the hydrogen ion or hydroxide ion. Okay, now we proceed to the question 2. Okay, calculate the pH. You are given concentration of alkali, strong acid, strong base. Okay, so from the sodium hydroxide, it will ionize completely to produce sodium ion and hydroxide ion. Okay, so for the initial concentration, this is 0.005. So initial concentration of product is 0, and the changes of concentration, okay, all base dissociates completely in water, so minus the total of the concentration, and at the product it will gain the same concentration as the reactant. Okay, so the final concentration, the reactant becomes 0, and the concentration of sodium ion is 0.005, hydroxide ion also 0.005. so this is our concentration of hydroxide ion. Okay, Now, by using the ionic product constant formula, Kw equal to hydrogen ion times hydroxide ion. So we can calculate the concentration of hydrogen ion. Okay, divide by 0.005. So the concentration of hydrogen ion is okay, 2 times 10 negative 12. Alright, okay, and then we can calculate the pH, negative log. Okay, then the answer is 11.70 pH. Okay, so this is alkali. Okay, alright, now we proceed to the third question. Calculate the pH value for the following at 298 Kelvin solution. Okay, now I want to share the two methods. Okay, let's we come out. Okay, this is as a summarization. Let's we come out the formula. If we want to calculate pH, we can calculate pH from concentration of hydrogen ion. If we have a pH, we can calculate the concentration of hydrogen ion. So equal to negative pH. Okay, this is second formula. The third formula is Kw equal to concentration of hydrogen ion times concentration of hydroxide ion. Okay, the another formula, 14 is equal to pH plus pOH. Okay, 14 is equal to negative log concentration of hydrogen ion. Okay, plus negative log concentration of hydroxide ion. Okay, so this is a few formula, okay, that you must know that we can use in the pH scale exercise. Okay, now please refer on question A. Okay, so you are given concentration of sodium hydroxide. Okay, sodium hydroxide aqueous ionized completely to produce sodium ion aqueous plus hydroxide ion, so aqueous. Okay, right, so the concentration 0.010. This is initial 0, 0. Okay, the changing of concentration minus 0.010, and the product will produce the same concentration as reactant, 0. Okay, so the final, okay, this one becomes 0, and the final of concentration hydroxide ion is equal to the concentration of sodium hydroxide. So this is our concentration, hydroxide concentration. Okay, next. Okay, now we can calculate the hydrogen ion, concentration of hydrogen ion equal to Kw divided by hydroxide ion. Okay, 0.01, and the answer is okay, 1 times negative 12, and the pH value is equal to negative log and equal to 12. Okay, this is first method. Okay, the second method is, okay, second method, we can use 14 equal to pH plus pOH. So 14 equal to pH plus, okay, pOH is equal to negative log concentration of hydroxide ion. So pH is equal to plus negative log 0.01. So 14 equal to pH plus 2. Okay, then pH is equal to 14 minus 2 and equal to 12. Okay, so this is the second method that we can use this formula. Okay, the first method we use this one formula. So there are two types of methods. Okay, all right, now we look at the question B. Question B. Okay, barium hydroxide aqueous ionize completely to produce barium ion plus 2 hydroxide ion. Okay, aqueous. Okay, so the concentration of barium hydroxide is 0.200. Okay, this is initial, and then the changes of concentration minus 0.200 barium hydroxide plus. Okay, so the hydroxide 2 times 0.200. Okay, and the final concentration return becomes 0. Barium is 0.200 molar, and hydroxide ion becomes 0.400 molar. Okay, so this is the concentration of hydroxide ion. Okay, we can use the formula. Okay, hydroxide ion equal to Kw divided by H plus, so 1 times 10 negative 14 divided by, okay, the formula is H plus this one hydroxide, okay, equal to 0.4, and the H plus is okay, 2.5 times negative 14. So pH is equal to negative log 2.5 times negative 14, and the answer is 13.60. Okay, this one is the first method. How about the second method? We can use 14 equal to pH plus pOH. Okay, so pH equal to 14 minus pOH. Okay, so 14 minus pOH is equal to negative log concentration of hydroxide ion 14 minus 0.4. So the final answer is 13.60. Right? So this is the second method. Right. So that's all for me to solve the calculation that related to the ionic product constant, concentration of hydrogen ion, concentration of hydroxide ion. Okay, that's all for me. Thank you.